Welcome to College Algebra. In this lecture video, we're going to talk about other common functions. So in 3.2, we talked about linear and quadratic functions. So here we're going to talk about your other common ones. So I kind of already drew all the common functions we will be talking about for this course back in 3.1. So here I'm just going to give you a little bit more different pictures to look at. Okay, so it's very crucial that you kind of remember what some of these functions look like. Okay, over time, it really helps. It really helps out when you do some of these problems. So I mentioned something called the polynomial functions before, and I believe I used cubic functions. So cubic function has exponent, okay, that is odd. So for this picture, that would simply be x to the third power. Alright, so when we flip it over, that will probably something like a negative x to the third power. Okay, even power, third power, just for example, any odd exponents, okay, like 3, 5, 7, it's all look pretty much the same thing. Alright, even exponent like x squared, x to the fourth. Okay, so just like parabola, the reason why we point downward for polynomial function because there's a negative sign in front, okay, of our leading term. So I'm going to use x to the fourth power, for example, here. Okay, so cubic function looks something like this. Even power looks something like this for polynomial functions. Alright, rational function of the form a constant number on top over x to the n power. Alright, so if I only have x to the n power in the denominator, if this exponent is odd, like the one I drew before, I think it was 1 over x. Okay, that's an odd exponent. It looks something like this. Okay, and another form looks something like this. So these two are for the odd ones. Alright, even power simply means maybe something like 1 over x squared. Okay, and to point downward like this is probably a negative 1 over x squared. Okay, so these are called reflection about the x-axis. We'll talk more about that in later on sections. Radical functions, okay, I think the one look like this is even exponent, like a square root. So I did not mention this back in the review. Okay, for any real number a to the m over n power, fraction exponent becomes our radical, where the denominator is the roots. The numerators tell you that the base is raised to that power. So when here we say odd exponent or even exponents, okay, that's simply referring to where the n is even or odd. So this, for example, will be like a cubic root function. So if I have a cubic root of x, okay, that will look something like this. And another way to write cubic root is x to the 1/3 power. Okay. So denominator determines the roots. So this direction is probably a negative cubic root of x. Alright, odd exponent 3, 5, 7. Okay. Even exponents, okay, like the square root I drew before. Okay. And this probably can be a negative square root of x, something like that. Okay, point downward. So reflection about the x-axis. Okay. So if I'm just kind of guessing right now, I can actually make sure what I'm doing is right. So if I do negative math cube roots number 4 of x, let's see if it looks just like this one. Okay, so I was right. It looks something like that. Alright, so there's a radical. Remember the absolute value function is a v, I mentioned before. Point upward or point downward. I didn't mention this one. It's called the greatest integer functions. Okay, sometimes I call these the step function. So to graph something like this one, if we go to y equal, go to math, highlight the word number, and go to the word called integer, number 5, and put an X in there, and that will display your step function. Okay, that would be look something like this one. So now there's one example on the homework. It's asking you something called the height and the distance. Okay, so what you can do is play around with this. So what happens if I insert 4 times in front of my integer, 4 times the greatest integer function? See what happens. So that gives me more gap between each steps. Okay. Alright, what happens if I will insert like a 4 times in front of the X that's inside of it? What does it do? Okay. Because we can't really tell what's going on over here. It looks like it's shooting up very fast. Let me change my window a little bit. Let me make it smaller. -5 to 5. I don't think I will see much of it when I be this tight. Worth a try. Oh, it's shorter. Okay, this thing looks shorter. So I wonder what happens if I do 1/4 of X. 1/4 is 0.25. Let's see what happens. Oh, this thing gets longer. Okay, longer, more gaps. So you can kind of play around with this. It's a very interesting type of problem that's used in computer science type of classes. All right. So what I'm going to do is for the following functions, we're going to identify the general shape for the graph. Then we're going to find 2 points on the graph other than the origin. So you can do integers, simplify fractions, or round to 2 decimal places as necessary. So what's going to happen here for the points is when you key in the points, the computer will graph it for you. So check it out. On your handouts, I believe there was like a 3rd page, okay, listing all the functions. Okay, so we're just gonna pick off from here. Alright, so identify the general shape. This is what kind of function. Don't let other things fool you, okay? The -4/3 that's in front of it can be rewritten as -4/3 times cube root of X. So this is basically a cubic root function, okay? But with a negative sign in front of it, that will make me choose which one of these, which one of the cube roots. These two is cube roots. With a negative sign in front of it, that will be this one. Okay. So that's the one we will select for the homework. Alright, now you can find any given 2 points. Okay, you can either do this by graphing it. I'm going to do one of these. I'm going to say -4 times cube root number 4 of X, close parenthesis, divided by 3. Okay, that gives me more precise graph. Ooh, let me okay. So this is a general shape you're going to select. Let me go back to the standard window. Here we go. We selected the general shape, and then step number 2 is 2 points. So you can go to table and find the whole number point. You can't use the origin, so just look around, see if you can see anything that's actually easy. Here's a little trick. That right there, -2.28. Highlight the y value. See, this is a lot more decimal than you think. Okay, so you can round to 2 decimal places, or you can type in a simplified fraction. if you cannot find any whole number answers, you can always use round your decimal places. Okay, got to key in 2 points for the computer to graph it for you. Alright, this is an absolute value function. So we know this is an absolute value function with a negative sign in front of it. Which one would you pick out of this list? Absolute value function is a v. Which one do I pick? Got to be the v that point downward. Okay, so that will be the general shape. There you go. Again, absolute value is under math. Highlight the word number 1. So you can type in -1/3 in the parenthesis and then times the absolute value of x. Close parenthesis. Okay, that will give you a v pointing downward. So it doesn't appear to be a v pointing downward, but that's what it is, since it's an absolute value function. Go to the table, get you 2 points. Alright, this one is x to the 4th power, so that's a polynomial function. So the general shape for polynomial functions gotta be look like a U. Alright, this one will point upward because this is not a negative. So we'll do that one right there. Alright. Don't let this problem fool you either, because if you kind of split this thing up, you can rewrite this as -8 over 7 times 1 over x to the 3rd power. So when you look at it from this perspective, okay, this is a rational function with an odd exponent, negative sign in front of it. Rational with an odd exponent. So these two is rational. These two is rational. Remember earlier we mentioned what? This 2 is the even exponent. Okay, so this is the odd ones. Alright, so if you're not quite sure which one to pick, okay, we can just give a try. I'm gonna just do the basic one, okay? I'm gonna do I'm gonna just do 1 over x. 1 over x. So this is a regular 1 over x. So this one right here got to be the -1 over x to the 3rd. Now why do I do x to the 1st? Because x to the 1st is an odd power. So it will look something similar to this form. Now there is a lot more about rational function that I will introduce later on. Right now it's just very, very basic, okay? Basic form. Alright, this is a radical function with an even root. Radical function, even root. You can actually graph this to get your 2 points, okay? Oh, by the way, don't graph this part, graph the original part. I'm just kind of split it up to let you see what the form is. So, even roots. Even roots. So you gotta be these two. With a negative sign in front of it, it will be this one right here that you will select. Alright. So once you make your selection on step 1 out of 2, then the second step, you can graph it and type in your 2 points. Or you can just make any, you can just kind of pick your points in your head and say, okay, put a 1 right here. 6 root of 1 is 1. So that'll be -8 over 5. X is 1, y is -8 over 5. You can do something like that, something quick like that. Alright. So kind of remember what these pictures look like will help you after you graph it in the calculator. You kind of have an idea what they look like. Alright, piecewise function. Real interesting. Piecewise function is actually a function that's made out of 2 or more other functions. Okay, with a certain constraints, we are only looking at certain part of each function. So what I mean is, for example, okay, this entire thing is a piecewise function. Okay, it's made out of two pieces. It's made out of a quadratic and a linear function. So if you think about it, okay, quadratic is normally a u. Alright, but the constraint tell you only looking at x that's less than -5. So that means everything to the right of -5 for x, you cannot look at that part. Alright, the other one is a straight line, only look at x that are greater than or equal to 8. So anything that is to the left of the 8, you do not look at. Without the equal sign down here, okay, you will use an open circle on the graph. Okay, so in a way, if you graph these two right here together, okay, on the graphing calculator, it's kind of hard to see because all you're gonna see is a parabola and a straight line. So you kind of have to picture it in your mind what they may look like. What do I mean by that is this. If you actually look at one of the very last example, okay, looks something like this. Okay, you kind of picture it. Alright, but now this particular example wants us to do some evaluating. Okay, go by the constraints. Okay, so the first one says evaluate this function at x equal to 8. So this part, the parabola is looking at x as less than -5. 8 is actually to the right of it, not to the left of -5. So when x equal to 8, we have to use the second one. So that means I will only substitute 8 into the linear function. So that will give me 4 times 8 minus 2. That will be 30, I believe. Alright, try another one. X equal to 5. You cannot take x equal to 5, put it into the parabola, because the parabola here is x that's less than -5. And so there's nothing here for 5. Right side of 8, left side of -5, there's nothing for 5, so that would be undefined. The function does not exist. This entire piecewise function, okay, does not exist at 5, because it only has to the right side of 8 to the left side of -5. So we'll say undefined. Alright. Evaluate at x equal to -6. -6 is to the left side of -5, so we will substitute into the quadratic function. So that will be 2 times -6 squared, and it says minus x plus 6 minus x plus 6. So if I put that in the calculator, raising to the second power minus parenthesis -6 plus 6, 84. Okay, so the y value is 84. Alright, now let's try to do the picture part. Okay, I'm kind of guide you through this. The steps guide you through. Identify the general shape of the graph of this function on the interval from -infinity to 2. So from left to the right, -infinity to 2. So according to the inequality, -infinity to 2 is referring to anything to the left of 2. So that's referring to the first, this function right here. 2 over x to the third. So that is a rational function with an odd exponent. Rational function with an odd exponent. No negative, so you got to be this one right here. So one of your picture looks something like this. Alright, now step 2 out of 3. Identify general shape of this function on the interval from 2 to infinity. From 2 to the infinity. So that will be this one. This is a linear function, okay? With a negative sign right here is we are having a negative slope, so that will be straight line going downward. That would be this one here. Alright, so let's check this out. Identify the correct graph. Alright, let's check it out. Remember the interval for the first one, -infinity to 2. The constraint tell you to only look at from 2 to the left. So let's go to x equal to 2. 1, 2, that will be right here. So from this point to the left of the graph. So what you do is you ignore the right side of this picture. Just that. Okay. Alright, here comes a straight line going downward, only looking at from 2 to infinity. Only look at from 2 to infinity. So find your 2. 1, 2. Only want to look at 2 to the right. So that means everything before this you ignore. Alright, so what does my picture look like? My picture look like, I'm just gonna kind of sketch it, okay? It's not gonna be exactly pretty. Alright, so let's say here's my x and y axis. And let's say 1, 2, because they keep on using the number 2. Alright, my function exists from here to 2. And I got the other side right here. Alright. So look at the inequality. There's no equal to. So that means once I reach 2, I still cannot be 2. So I use an open circle. Alright. The other part, okay, the linear function x is greater than 2. So that will be, let's look at this point. 1, 2. 2, -2. 1, 2. So the linear function will begin right here, keep on going downward. But there's no equal to again on that 2, so I'll use another open parenthesis. There you go. That's what your picture will look like. Okay, with 2 open circles. Now, if I ask you to evaluate x at 2, what would you say? Undefined. The function, this entire function never defined at x equal to 2 because I'm using 2 open circles. Okay? Alright, so this particular problem kind of guides you through how to do it. Now this one, more straightforward. Okay? First one is a linear function looking at left side of -2. Okay, left side of -2. So that could be this one, could be this one, could be this one, could be this one. Alright, so let's look at the second part. Quadratic function. It's a u open upward, looking at to the right side of -2. So that would be these two. Okay, cannot be these two. These two does not look like a u. Alright. A little trick. Look at the inequality. Inequality on the straight line got to be a solid circle here. For the u, it got to be an open circle right here. Alright. Another trick you can try is plug it in a -2 and see what happens. Because this one doesn't look like a u, but it can be a u. You know what I'm saying? We just don't see it come up. So it's about the y value too, okay? So solid circle on the straight line. Okay? So the parabola, parentheses, 3/4 times, okay, evaluate at x equal to -2. It is defined at -2. This is one of the two of them. Whole thing squared. It's 3. It's that one right there. Okay. Alright, so if you don't believe me, let's try -2 at the straight line. So I'm just kind of evaluate -2 for the parabola just to see where the y value is. Now if I do it for the straight line, -3 times -2 minus 6, the y value 0 right there. See, that straight line, the y value is 3, so it's trying to do it backwards. So your graph will be this one right here. Alright. Okay. So by understanding, by knowing these pictures for the different types of functions, does kind of help us, okay, to see what they may look like once we graphed it. Because it's really hard to argue that, okay, is that a straight line? Not necessarily, because once we go outside the window, this thing can actually begin to curve up like that. So, okay, so if you know that, then you'll be able to know to check for the y value. Okay, make sure the y values are where they need to be. Okay, alrighty. So, down the road, we will talk more about these functions, especially for your test number 2. We'll talk more about the little things about each one of these graphs. Reflection about the x-axis, y-axis, open wide, or your graph will open wide or open narrow, things like that. Alrighty, thank you for watching.